Welcome back. This is the second lesson recording for IM2, March 18th, 2021. So where we left off, we have two different solutions. X is equal to negative 2 plus root 3 or x is equal to negative 2 minus root 3. Okay, another problem. Which method can be used? X squared plus 6x is equal to 16. Now in this case, because we have an x term, we cannot use square rooting. That means we have choice between zero product or quadratic formula. Either way, I need to bring the 16 to the other side. So I am going to subtract 16 from both sides and you're left with x squared plus 8x minus 16 is going to be equal to 0. Alright, so now can I factor this? Well, the a is 1. There is no number in front. That means the default number is 1x squared. So this is going to be a simple factoring if it is factorable. So let's try factoring as usual. So then we put x here and x here. I'm looking for two numbers that multiply to negative 16. The factors of negative 16s are 1 and 16. If I add, one's going to be positive, one's going to be negative. If I add positive and negatives, the difference is not going to be 8. What about 2 and 8? The difference is not going to be 8. What about 4 and 4? 4 and 4, the difference is going to be 0. So I know that this is not factorable. Okay, so not factorable. That means at this point, I should be using quadratic formula. So x is equal to negative b. What is b? Well, I should write it down. A is equal to, what is the number in front of x squared? That's 1. B is equal to 8. And c is equal to negative 16. So x is equal to negative b, so that's going to be negative 8 plus or minus square root of b squared, that's 8 squared, minus 4 times a is 1 times c is negative 16 all over 2 times 1. Then you start to simplify. Okay, do not skip any steps because again I said the quadratic formula is very error prone. 8 squared is 64. Now negative times negative is going to be positive. So 4 times 16 is going to be 64, which is over 2 right there. And then that simplifies to negative 8 plus or minus square root of 64 plus 64 is going to be 128. Keep that in mind that that is made up by 64 and 64, which is a complete square, a perfect square. So then that simplifies to negative 8 plus or minus square root of 128 could be simplified as 64, square root of 64 times square root of 2 all over 2, which is same as negative 8 plus or minus square root of 64 is 8 root 2 all over 2. And I can split this as negative 8 over 2. I can divide each of the terms separately. Plus or minus 8 root 2 over 2. So that simplifies to negative 8 divided by 2 is 4, negative 4. And plus 8 divided by 2 is also 4 root 2. So that's my x value. That means I have two solutions. I have two solutions. One of the x could be negative 4 plus 4 root 2. Or the other solution is x is equal to negative 4 minus 4 root 2. Again, always simplify the radicals whenever possible. And use I if you need to. Next objective is that you can identify a complex number and represent it using I. Remember, what makes a number complex? The answer is any square root with a negative number inside. So if you have a square root with a negative number inside, then it's going to be complex number because you're going to end up with an I somewhere. Okay. What about this? I have a negative number here, but what is the final result? 6 squared is 36 minus 8. That's going to be square root of 20 8, which is a positive number. Okay, so let's just keep simplifying and let's figure out how to do this. For the first problem, I have square root of negative 32. I can simplify that as square root of 16 times square root of 2. Again, I chose 16 because 16 is a perfect square. Then multiply by negative 1, okay, to get negative 32. Then I know that that simplifies to 6 plus, what is square root of 16? That's just 4 root 2. And square root of negative 1 is just I, all over 2. That means, remember, I can separate divide by 2 into each of the terms in the numerator. So that becomes negative 6 over 2 plus 4 root 2I divided by 2. Then I can, negative 6 divided by 2 is negative 3. 4 divided by 2, that just becomes 2. So that becomes plus 2 root 2I. Notice that because I am dealing with negative square root, I have an imaginary portion to it. That means this is going to be a complex number. What about the next problem? 5 plus square root of 36 minus 8. 36 minus 8 all over 2. And even though we have a negative here, the end result is you're not going to end up, whoops, there shouldn't be a plus or minus. The end result is not going to be negative. It's going to be square root of 36 minus 8 is 28. That is positive square root. Okay, so we don't have a negative number inside the square root. That means this is not going to be a complex number. So we can still simplify this, because 28 can be broken up as 4 times 7. And again, I chose 4 because 4 is a perfect square. And that's going to be 5 plus 2 root 7 over 2. And that can be re-represented as 5 over 2 plus, okay, 2 divided by 2 is going to be root 7. So there is no I involved here. Okay, so this is not a complex number. This is a real number. Okay, next objective, that you should be able to find the roots of a function either algebraically or graphically. So what are the roots of a function g of x is x squared plus 8? Well, you should be thinking, what does root of a function mean? Roots are solutions to the equation x is equal to x squared plus 8, because what is a root? Root is a value of x that makes the output to be 0. The output is g of x, so we want the g of x to be 0, and we're looking for x value. Think, what method would I be using to solve this equation? X squared plus 8 is equal to 0. What's the easiest way? Well, hopefully you're telling me square rooting, because you just have something squared plus constant is equal to 0. Okay, so that means I can bring the plus 8 to the other side by subtracting 8, so you have x squared is equal to negative 8. Then from here, what do? I have take the square root of both sides, and remember, this is when you get your plus or minus sign. Do not give it to me right at the end. I want to see it right here as part of your work. So then here, the x squared and x cancels out, and you're left with x is equal to plus or minus, what is square root of negative 8? I can break up the negative 8 as square root of 4 times square root of 2 times square root of negative 1. Which means this is going to be plus or minus, square root of 4 is 2, root 2, and square root of negative 1 is just I. So my two solutions are x could be positive, x could be positive 2 root 2I, and x could be negative 2 root 2I. Okay? And what sort of roots do I have? Do I have complex solution, or do I have real solution? Because I have imaginary number I, there we have two complex roots. We do not have any real roots. We just have two complex roots. Okay, what about this? I can find the roots of a function either algebraically and graphically. That means you should be thinking, if there are x-intercept, are they roots? Are they always going to be the roots? Well, in this case, we have, it's an upside down parabola because we have the leading coefficient, or the -1 is being multiplied to it. And the roots are -2 and +8. Okay, so we have two real roots. What about this? The x-intercept is -8, and x could be, when x is equal to -8, y is going to be 0. That is the reason that this -x is equal to -5 is a root. What about this? We have no x-intercepts. However, we can figure out the complex roots. Okay, so even though we don't have any x-intercept, that does not mean that we do not have any roots. We do have two complex roots. Now we're going to get together as a class and work on some application problem. A toy rocket is launched vertically upward. Its height h after t seconds is given by the equation h of t is equal to -16t squared plus 128t. Okay, so how long will it take for the rocket to return to ground? Okay, so what is it asking? Well, h is the height of the rocket. If it is returning to ground, then the height is going to be 0. So we're saying that for when it returns, the height is going to be 0. So we're going to set h of the output to be 0 is equal to -16t squared plus 128t. Okay, what is the easiest way to solve this equation? You might be saying, oh, but the numbers are big, so I should just go to quadratic formula. No, 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 no. This is easily factorable because I'm missing the constant term here, right? So that means I can take out t as one of the factors, and this 128 is also divisible by 16. So I can actually take out -16t, and that leaves me with t, and -16 times -6 is going to be positive 120t. So this factors to -16t multiplied by t minus 6. That means when the height is 0, t is either -16t is equal to 0. That means t is equal to 0. That's in the beginning of the rocket launch. Or t minus 6 is equal to 0. That means t is equal to 6 seconds. Okay, so I know that it will take, in the beginning at t is equal to 0, the height was 0 because that's when it was launched, and after 6 seconds it hit the ground again. Okay, now how long will it take the rocket to hit the maximum height? Well, if the two intercepts, x-intercept, or when height is equal to 0 is t is equal to 0 and t is equal to 6 seconds, then we know by symmetry we're looking for the vertex. And the vertex is going to be halfway between 0 seconds and 6 seconds. So t is going to be 0 plus 6 over 2, which is 3 seconds. And then what is the maximum height? That means we can substitute at t h of 3, because the time is 3, to figure out what is the height. So that becomes t is 3 squared plus 128 times 3. So use the calculator. So -16 times 9 is going to be -144, and 3 times 128 is going to be 384. Notice that we have a negative sign here. Do not lose those. So 384 minus 144 is going to be 240. Okay, it did not tell me what the height is measured in. If it was measured in meters, or feet or whatever you